All right, good afternoon, boys and girls. We're on lesson 103, which is on symmetry and transformations. Today, we're going to be able to find lines of symmetry in figures, and we're also going to determine if a figure has rotational symmetry. Here are your vocab words for today. Line of symmetry, which is the imaginary line where you could fold the image and have both halves match exactly. Reflective symmetry is where figures that can be divided by mirror images. Rotational symmetry is a figure has rotational symmetry if it regains its original orientation more than once during a full rotation. So if you're going to turn something, and if it looks the same when you turn it, it has rotational symmetry. Here's your math joke. David says, "Why did the broom get a poor grade?" Dan says, "I don't know why." And David says, "Because it was always sweeping during class." All right. Here's your new concept. In this lesson, we're going to look for lines of symmetry. We're going to figures that can be divided into mirror images by at least a line of symmetry are said to have reflective symmetry. If you place a mirror along the lines of symmetry, the reflection appears to complete the figure. Now, if you look here, um, this is a line of symmetry, okay? Basically, what you can do is you could fold it at the line of symmetry, and then you'd have nothing overlapping, right? It'd just be one piece. And if you were to put a mirror next to it, right, you would have the exact thing. It would complete the figure at that line of symmetry. So on either side, it would complete the figure. So that was a line of symmetry, and then this would be a reflective line of symmetry as well. Because if you put a mirror up, it would have the same reflection and complete the figure. So in example number 1, we have a triangle and a regular pentagon, and we got to figure out how many lines of symmetry it has, okay? And so what we're going to do is um, a line of symmetry passes through a vertex and splits the opposite side into two segments. All right, most of the time, lines of symmetry will pass through the vertex. It doesn't have to, but in this case, it will. All right, so um, if we put a line right down the middle of this triangle, we can see that we have two sides. And if we were to put a mirror up here, we can find that that will complete the triangle if we do put a mirror up there. Okay, so we know that these are lines of symmetry. Same thing if we do this. If you fold this right here in the middle, the folds would match up. That's how you know it's really a line of symmetry, if the folds match up. Alright, since these polygons are regular, we find a line of symmetry through each vertex of the polygon. So we're going to put a line of symmetry on each vertex, and then if it folds up, it is a line of symmetry. And then so each one of these on this hexagon, or pentagon, excuse me, is a line of symmetry, right? So a regular triangle, like this one, has 3 lines of symmetry, and a regular pentagon has 5 lines of symmetry. All right, here we have a regular quadrilateral and a regular hexagon. So we're going to find lines of symmetry in each of these figures. There's a line of symmetry that passes through the vertex and the opposite vertex, right? So remember, the vertex is where 2 lines meet and it comes to a point. That's a vertex. So there's a vertex here, and this one does pass through, and it is a line of symmetry. Remember, if you could fold it and it's equal, then it is a line of symmetry. All right, so we do that here, and we find that these are also lines of symmetry at all of these vertices, excuse me. And then we can also cut these in half and find that there are lines of symmetry that go through the sides of the figures, like this. It's not going through any point, but going through the middle of the figure. Okay. Same thing here. Again, we find lines of symmetry for the square and 3 for the hexagon. And then we total up the lines of symmetry, and in all we have 1, 2, 3, 4 lines of symmetry for the square, and we have 1, 2, 3, 4, 5, 6 lines of symmetry for the hexagon. Now for rotational symmetry, it's a little bit different, okay? What rotational symmetry is that if you were to turn one of these figures, when will it regain its original shape, right? So if we turn M around and just keep turning it clockwise, we'll find that M will only be another M until it turns all the way around, right? But an A, same thing. If we turn it, it will not be an A until it's all the way turned around. Same thing with T. It will not be a T until it's turned around. H is the only one. See, if we turn this, if this was the bottom and we turn it to the top will now be at the bottom, right? And so if we rotate this 180 degrees, which means halfway, we'll find that it has a rotational symmetry because it will see an 8. You'll see an H when you rotate it. Okay, so that's what rotational symmetry is. So if you turn, say, a box around, and it looks the same after you turn it halfway, then it does have rotational symmetry. Same thing with this letter H. If you turn it upside down, it still looks like an H, right? If you turn this T upside down, it looks like a stick on a piece of dirt or something, right? It looks like an I without its top missing. And the A will look like a V when you turn it upside down. The M will look like a W. So these don't have rotational symmetry. Remember, rotate is the key word here in rotational symmetry. When you rotate it, if it looks the same after you rotate it, it has rotational symmetry. All right, on the grid, there's an L-shaped figure and it's a reflection. Is there a line of symmetry between the figure and the image? All right, so can we draw a line of symmetry in between here? And it will be, if we fold it in half, they would meet. And the answer is yes. This L would be flipped over to this side, and so our line of symmetry is right down the middle. Okay. So this line of symmetry is a line of reflection, right? If we put a reflective surface right here, this would show up like this in the mirror. Okay, and so that there is a line of symmetry with these figures, and it's right here in the middle. On a grid, an L-shaped figure is translated 4 units to the right. Is there a line of symmetry between the figure and its translated image? So if we look from here to here, with the translation, if we put a line of symmetry down the middle and we fold it, will it equal the same thing? No, they wouldn't meet up. All right, so there is no line of symmetry between these two figures. All right, now on example number 6, on the L-shaped figure is rotated 180 degrees, right, from this point A. The original figure on its image are combined to form a new shape. Does the new shape have rotational symmetry? All right, if you rotate it, is it gonna have rotational symmetry? And it's yes. If we turn our books 180 degrees, if we turn this image 180 degrees, we'll have the same figure. Okay? And now the answer says if the figure were rotated any other number of degrees greater than 0 and less than 360, then the figure in its image would not have the rotational symmetry. But it does at 180 degrees. So if we turn this upside down, it would look the same, right? So then we can conclude that it does have rotational symmetry. Let me just go back really quick before we go to our lesson. I just want you guys to get this. Rotational symmetry. Okay, rotational symmetry, where is that? There you go. It's a figure has rotational symmetry if it regains its original orientation more than once during a full turn. So if you're going to turn this whole rectangle upside down and it looks the same upside down, then it does have rotational symmetry. Okay, so and then you turn it right side up again, it has the same picture more than once. All right. All right. Let's go to our lesson practice. Oops, there it is. So in letters A through D, you're gonna draw all the lines of symmetry in these figures. Okay. Be leery about B. All right. B is not a square, so make sure that you don't draw unnecessary lines of symmetry because if you fold it along that dot, is it gonna look the same, or are the sides gonna match up? All right. So that's how you think about these things. If you're gonna draw a dotted line down the center here and fold it where the center is, or wherever you drew that dotted line, is it going to match up? All right. Okay. Um, letter F. So letter E, you're gonna have to draw your own octagon, and then figure out the lines of symmetry on an octagon. Letter F, you're going to rotate these letters and figure out which one of these letters has rotational symmetry when you rotate it. Okay. And then you're gonna copy this whole thing onto letter G. If you need to use the back of your paper, use the back of your paper. Then draw the image of the reflection across the horizontal line here. All right, so if you were to put a mirror up here and on your paper, you can do that. You can take a mirror at home and put it on this line of symmetry and see how it reflects up here on the top. Okay, so figure that out. If you have any questions, feel free to write those questions on the back, and we look forward to answering your questions in class. Have a great day.